All right, so unit number 6 focuses on working with different types of functions, working with most specifically radical functions. So this one is a mixture of a unit that first deals with the concept of a function operation. So a function operation is simply taking two functions and either adding them, subtracting them, multiplying, or dividing. So literally nothing new than what you've already done. What's important in this particular unit, however, is the fact that you're going to get a lot of different notation that you're going to have to understand what goes with what. So addition is written as f plus g parentheses x. This does not mean distribute. That's not what that means. F plus g of x means f of x plus g of x. Take the two functions and add them together. Subtraction, f of x minus g of x. Multiplication, f of x times g of x. Division, f of x divided by g of x. So what you have here is the notation. It's a notation. So the directions might not say add these two functions up. They might give you the notation, and you'll be expected to know that that's what that means. So adding, subtracting, multiplying, and dividing, it's not any different than what we've already done. If you have two functions and tell you to add them, combine like terms. If they tell you to subtract them, keep, change, combine like terms. They ask you to multiply, distributive property, FOIL, do what you need to do. Division, set the two problems up to divide, set them up as a fraction, divide them if possible. So it's not anything that's entirely brand new. Now what will be a little bit brand new is the idea of finding the domain after you add, or after you subtract, or after you multiply. So this answer is pretty simple. It's all real numbers. It's all real numbers unless you have a fraction. So if you have a fraction, remember you can't divide by 0. So you got to find out what will make the denominator equal to 0, and you eliminate that from the domain. So it's not as hard as it sounds. One of our examples is a division example, so you'll see how that works. Main thing here is you got to know the notation. If you don't know the notation, in many ways you're screwed. So you got to know the notation. Any questions before we do our first 4 examples? So as I mentioned, primary thing that you must know how to do is to understand notation. So let's start with our first 4 examples. So working with these problems, you're going to be given functions to start with. You're going to be given functions to start with. So f of x equals x squared plus 7x plus 12. G of x equals 3x minus 4. They gave you 2 functions to start with. So example 1, you have f plus g of x. So that, in layman terms, means add the functions. That means add the functions up. x squared plus 7x plus 12, 3x minus 4. So if you add the functions up, this is nothing more than combining like terms. So x squared plus 10x plus 8. So we combine like terms. As far as the domain goes, domain is asking you what numbers can I plug into the function. In this case, there's no limit to what I can put into this function because it's not a fraction. So negative infinity to positive infinity, or all real numbers. There's the f function. That's the g function. That's not that. So you didn't hear what I said at the beginning either. That does not mean multiplication. So f plus g means add those two functions up. X is the variable that's inside of both of them. So I'm glad Victoria asked that question. You're going to have to know what the notation means. Otherwise, you are going to royally screw up some of these problems. You've got to know what this notation means. So I would much rather you ask than start assuming. That's not multiplication. This does not mean multiplication. That means add two functions up. So again, if you're stuck, you gotta ask. Especially if you're one of those people that tried to photomath that test and got caught. Let's do example 2. So example 2 is a little bit more straightforward. F of x minus g of x. So you're subtracting the two functions. If it was written like that, that still means the same thing. You're still subtracting the two functions. So it's still a subtraction problem. So it's still a subtraction problem. Subtract two expressions, keep the first expression, distribute the negative into the second expression, and then combine your like terms. Okay, if I mess up with the simplifying somewhere, make sure you say something. So so we finished simplifying. There's no fraction. That means there's no restrictions. So your domain, negative infinity to positive infinity, or all real numbers. Questions 1 or 2? All right, problem 3. So f dot g of x. So that's f times g of x. F of x times g of x. So this is a multiplication problem. X squared plus 7x plus 12, 3x minus 4. So you multiply it the same way you would multiply two expressions. So if you distribute, you have 3x to the third, 3x to the third, plus 21x squared, plus 36x, minus 4x squared, minus 28x, minus 48. Took the first expression, multiplied it times 3x. Took the first expression, multiplied it times negative 4. That's what you have. Now you combine like terms. Plus 8x minus 48. So we finished our multiplication. There's no fraction involved, so your domain is still negative infinity to positive. So adding, subtracting, multiplying, most of the time, you're going to get domains of all real numbers. It's division where the domain is going to change. So f divided by g. So that's a division problem. So that's a division problem. Same thing as f of x divided by g of x. So f function divided by g function. So we have the problem set up. We have the division set up. Side note, if they don't ask you to do long or synthetic division, don't do it. This is okay legally. But this is not, the domain is not negative infinity to positive infinity. If it's a division problem, you have a rule. You cannot divide by 0. You can't divide by 0. So that means we need to figure out what x value is going to make the denominator 0. That's not that difficult to figure out. Take the denominator, set it equal to 0, and solve it out. So that means if I put 4/3 back into that problem, the bottom of the fraction is going to be 0. And I can't divide by 0. So that means 4/3 cannot go in my domain. So your domain is x cannot equal 4/3. X cannot equal 4/3. Any questions? Example 4. You can leave it as a division problem. That part's fine. It's the domain that you have to take care of. You have two answers. One is your setup for the division, and one is your domain. You do not have to simplify it unless they ask you to use long or synthetic division to it. Any other questions? 1, 2, 3, or 4? All right, not hearing or saying anything. Let's go on. So adding, subtracting, multiplying, dividing, we've done those quite a bit over the course of the year. The fifth operation is the newest operation for a function. That's called composition. So composition is when you take the answer of one function and you plug it into another. Take the answer from one function and you plug it into the other. We're actually doing this quite a bit when you were solving systems by substitution. You're taking one answer and you're plugging it into another. So as far as composition goes, this is the notation. So one notation looks like the word fog. And one notation looks like one function inside of another. So these are the two notations for composition. So in English, this would mean f of g of x. That's how you would pronounce it. F of g of x. A composition problem is an inside-out problem, meaning you're going to start from the inside and you're going to work your way out. You start from the inside, you're going to work your way out. Start from the inside, work your way out. So we explain to you what this means before we try some examples with it. Let's say you had numbers. F of g of 5. So what this means is take 5, plug it into the g function, get your answer. After you get that answer, so take 5, plug it into the g function, you're going to get an answer. Once you get that answer, you take that answer and you plug it into the f function. So whatever answer you got, you plug it into the f function. So that's what a composition is. You're taking one function and you're plugging it into another. If you didn't have a number, then you would just work with the whole function. So g of f of x means you take the f function and plug it into the g function. Take one function and plug it into the other. composition is something that you, one, don't want to sit and try to rush through, and two, you don't want to probably do at 2 o'clock in the morning. That might be bad. But now we're going to practice doing just composition. So let's practice composition. So just like with the first 4 examples, I'm going to give you some functions to start with. So remember, composition are inside-out problems. Start from the inside, work your way out. So f of g of x means you're going to take the g function and plug it into the f function. Your f function is 4x. Your g function is 2x minus 3. So that means you're going to take the g function and plug it in for x. Just like when you were solving systems by substitution. Substitution problem. And after that, you solve it. Let's simplify. Problem's over. There's still no fraction, so your domain is all real numbers. Any questions? Example 5. Because you're plugging it into a function. You're taking 2x minus 3 and you're plugging it in for x. So that x has to come out because you're plugging something in for it. It's just like if you were doing it with the number. If you had a number, you wouldn't leave the x there. You would take the x out and put the number in. Same rule applies if it's a function. You take the x that's there out and plug in the function. Good question. Anyone else with questions before we do example 6? All right, let's do example 6. So you have h of g of x. So h of g of x is the same thing as h parentheses g parentheses x. Take the g function, plug it into the h function. So your h function is x squared plus 4x plus 5. Your g function is 2x minus 3. So notice your h function has 2 x's. Everywhere you see x, you're going to plug in 2x minus 3. So everywhere you see x, you're going to plug in 2x minus 3. It's the same thing you would have done if it was a number. same process as if it was a number. You're just doing it with another function. You can't leave it like that, so you have to simplify it. 2x minus 3 squared. Remember, you write it twice, and you do FOIL. So that's 4x squared minus 12x plus 9. You write it twice, and you do FOIL. So by all means, if you need help with simplifying now, ask me after class, and I'll show you how that simplifies out. But you write it twice, and you do FOIL. 4 times 2x minus 3, 8x minus 12, that's 5. And you simplify. Still nothing wrong with that function, so your domain still negative infinity, positive. Any questions for U7? All right, so let's do 7. Problem 7, you have g times g of x. G of g of x. So that means you take the g function, plug it into itself. There's no rule that says you can't take a function and plug it into itself. So the g function was 2x minus 3. So you're going to take the g function and plug it into itself. No rules that says you can't do that. Might be weird, but there's no rule that says you can't do it. And you simplify it. Still no fraction, so your domain is all real numbers. Any questions, 5, 6, or 7? All right, then last bit, we'll actually use some numbers. We'll actually evaluate. So let's do a little evaluating. So we got 3 new functions. So don't expect the functions to be the same all the time. Almost always there's a change now. So you have f minus g times h of negative 4. So you have f minus g times h of negative 4. So this is the same thing as f of negative 4 minus g of negative 4 times h of negative 4. Take negative 4, plug it into the f function. Take negative 4, plug it into the g function. Subtract your two answers. Times, take negative 4, plug it into the h function to get your final answer. So, my advice for all of you, do it in parts. Do not try to do it all in one stream. Do it part by part. Do the problem part by part. You can either take your time and do it right, or you can take your time in doing it over. So f of negative 4 means take negative 4 and plug it in for x. That will give you negative 16 when you finish it. G of negative 4, take negative 4, plug it in for x. So 16 plus 20 is 36, plus 4, 40. H of negative 4, negative 1/2 times negative 4 minus 7. That's negative 5. Negative times negative is positive. Half of 4 is 2. 2 minus 7 is negative 5. So I've got my individual parts. So now this problem ends up being f of negative 4, which is negative 16, minus g of negative 4, which is 40, times h of negative 4, which is negative 5. So the main people who are going to get confused are those people who try to do it all at once, or those people who don't want to do all the work and will find little ways to make mistakes. I can't do anything about that. You can take your time to do it right, or you can take your time to do it over. So from there, this is just a simple order of operations problem. 16 minus 4. Negative 16 minus 40 is negative 56. Negative 56 times 5 is 280. That's the end of the problem. Say that again. You don't have to put the domain if it's asking you to find a value. If you still had x's in the problem, then you'd have to find the domain.